Assalamualaikum warahmatullahi wabarakatuh. My name is Athirah Syamimi binti Baharudin. My matric number 196609. So I will presenting about the report I already reviewed on um, on a research, uh, and the topic is development of statistical method to help evaluating the transparency opacity of decorative thin film. Basically, this research is mainly about the how they want to analyze the color of the decorative thin film if they put uh, if they put on different substrates. So in this research, they are mainly focused on to develop the statistical method in this research. So for the introduction of this research, statistical method, they use statistical method that allows evaluating the degree of a transparency of a thin film. So they want to evaluate how the statistical method can produce the degree of transparency of a thin film that they will use a standard deviation. So the color coordinates are measured on different substrates such as silicons, glass and steels, and the standard deviation will be evaluated. And the color depends on the film and not on the substrate, and intrinsic colors are obtained. This is mostly will appear in case of low values that the color will depends on the film and not on the substrate. So for this research, they use zirconium asymmetric films that will be deposited by reactive direct current magnetron sputtering in a laboratorial size deposition equipment onto three substrates like I will uh, I already explained earlier, which is they use glass, steel, and silicon. So, main question is why this statistical method being used by the researcher. So, it is mainly to obtain the standard deviation of the color coordinates of the three substrates that were already stated just now when the films are deposited on different substrate. So, according to this experiment, we will get if the standard deviation will decrease, it means the color of the coatings deposited on different substrates is similar. If the standard deviation will increase, it means the film deposited in different substrates will cause a variation of color coordinates as a consequence of the color of the substrate. So it will depend on how the standard deviation will be evaluated through the experiment. So based on this, based on this schematic representation, this is the representation on how to calculate the standard deviation of the color coordinates from substrate to substrate. So the final L, A, and B parameters for a film. This is the parameters for a film in one batch. Are the This will be the average values of all the measurements of the three samples of the batch is glass, silicon, and steel. So it will depend on these L and B parameters. So from this research, the researcher already identify that there will be three possible ways on how to calculate the overall standard deviation of a set of values with their own SDs. So from this figure 2, this is the scheme of the three different situations to calculate the overall standard deviation from 3 points, which is will depends on this situation. So for the A, the standard deviation of the points is much smaller than the expression of the points, which is we already saw that this is much smaller than the expression of the points. So the SD bars are small when compared with the dispersion of points. Therefore, the main contribution to the overall standard deviation should come from the dispersion. As the points is much smaller, so the main contribution of the standard deviation will be from the dispersion. So from region C, we could see that the standard deviation of the points is much larger than the separation of the points. So from this C, we will use the standard deviation. The main contribution to overall standard deviation of the data will become from its own standard deviation. So in the intermediate situation, in B, which is the standard deviation of the points, is in the range of the separations of the points, which is both components, which is the dispersion that we'll use in A and the standard deviation and the individual standard deviation that we'll use in C can apply in can contribute to overall SD standard deviation in B. So from this scheme, we will understand that the situation is depends on the dispersion of the points, or dispersion of the points or its own SD standard deviation. So from the researcher, they already identify how to calculate the standard deviation. The mathematical development was performed in order to calculate this overall standard deviation of any of the cases. So they will use all the mathematical development to produce a calculation for standard deviation. So from here we could see the overall standard deviation of a set of n data. Xi is the square root of its variance. The variance of a set of n data Xi can be written as in the equation 1. So the situation in the case of the determination of the color of the samples is that instead of having the n originals value, there are m pairs. So this is the development of mathematical development of mathematical that already find out by the researcher until equation 10. And from the mathematical development, they will use the equation at education 8 because from the equation, this equation, it calculates the overall standard deviation of a color coordinates among the three types of substrate, silicon, steel, and glass, deposited in the same batch. So this expression should be valid for any relative weight of the contribution of the M average and the standard deviation to the overall standard deviation for the three situation that already figure in figure 2 that I have already present about that they will use the dispersion or their own individual standard deviation just now. So if the value of the deviation is close to 0, it means the color will appear is intrinsic color. So from this data, we could see this is the color coordinate of L, A, and B for the films deposited with different reactive gas flows on different substrates. From region A, it characterized by similar values of color coordinates regardless of the substrates. So we could see that the points is not on its way on this region. So in the second zone, the values start to deviate. It already deviate depends on the substrates. So we could see in the region B, the value is already start to deviate. While in the third zone, which is the C zone, the color coordinates vary strongly when different substrates are analyzed. So we can see uh, the the coordinates vary strongly because different substrates are analyzed. In C, significant lower thickness of the films, which will induce the interference effect out of the visible region. So therefore, we could see the films in region A are characterized by clear crystalline structures formed by metallic ZR nitrides and or oxynitrides. So from this slide, we could see the scheme of the three regions distinguished in the samples in terms of color with the increase of the standard deviation. So we could see in region A, the substrate and the film, it will reproduce the color with standard deviation, low standard deviation. In the glass, in the region B, the color of observed will be medium because the standard deviation is in intermediate, and we could see in the region C, the color observed, which is it will be a high standard deviation. So we could see in these films, as the films become transparent, the deviation, standard deviation will increase. So the transparency of the films will be depends on the standard deviation. If the standard deviation increases, so the films getting more transparent. So for this research is reference as uh, this research mainly uh, from CI da Silva Oliveira, de Martinez, E. Alrejo, L. Robuta, R. Menezes, and L. Chunha, which is the topic of the research is a development of a statistical method to help evaluating the transparency or opacity of decorative thin film. So this is an applied surface science that use statistical method in their research for thin films to observe the transparency of thin films. So that's all from me. Thank you for hearing my presentation. Thank you.